So, Namaste, welcome to the class on the nets of 3D shapes. You know that mensuration is a very important chapter. It is a part of geometry. It is concerned with the volumes, areas and other, of course, we can call it as a perimeters also. These are the three important areas for any figure. Here there are two kinds of things. One is called two-dimensional and the second one we call it as a three-dimensional. You know that two-dimensional figures like rectangle, circle, square and other things. And three-dimensional means a cuboid, cube, cone, cylinder, pyramid, all comes under the 3D shapes. Generally you have a doubt on that. The first one is you said two-dimensional. For drawing a circle, so one dimension is enough, the radius is enough, am I correct? Then where is the second dimension? For drawing an equilateral triangle, one dimension is enough, then where is the other dimension? So, the question arises in the minds of the people. Here it is not with respect to dimensions here, whether you are able to draw the figure or represent the figure on a two-dimensional plane, then it is called it as a two-dimensional object. If it is unable to draw it, represent in a two-dimensional plane, it is possible to represent on a three-dimensional space, that figures are said to be 3D shapes. Is it clear? So, where you are representing, that dimensions will be considered as 2D and 3D. Here you are seeing some 3D shapes. So, if you want to understand the 3D shapes, you have to understand the nets. That is very important. The net of a shape is what it looks like when it is opened out as a flat. That is a definition of a net. You are seeing a cube, a triangular prism, okay, pyramid and other things. So, here the cube, it is a 3D figure, you know that. When you open it, the net diagram as shown below to the cube. When the triangular prism is opened as shown in the below of the triangular prism, like a square based a pyramid shape also. So, that is a very important. Okay. So, here I am using three words, one is called perimeter, second one is called area, third one is volume, correct. Generally we are using for a two-dimensional the first two, that is area and perimeter. So, what is meant by perimeter? Perimeter is sum of all the sides. For example, if it is a square, it has 4 sides, so its perimeter is 4 into side. If it is a rectangle, it two dimensional, one is called length, another one is a breadth. So, it has 2 lengths and 2 breadths. So, its perimeter is 2 times of length plus breadth, clear. So, like we can say the perimeter. Perimeter of a triangle is simply sum of all the 3 sides. For example, if you want to represent it with A, B, C, the lengths of the triangle, then its perimeter is A plus B plus C, clear. So, like we can say the perimeter. When you come into the area, so what is the area here? How much area was occupied by the object, we call it as area of the object. That is a very important. So, for a square the area is side of side, for a rectangle the area is length into breadth, for a triangle the area is of base into height, for a circle the area is pi r square. So, like we can say the areas of the things. Now, coming to the three-dimensional figures, here we are not using the word call it as a perimeter, we are using the area and the volume. But area is two kinds here, that is first one is called as lateral surface area, a second one is called total surface area. So, area will be, so when you first one you call it as a lateral surface area. So, what is lateral surface area and what is total surface area? Generally it has any three-dimensional figure has its faces. Okay. When you consider the areas of all the surfaces, including top and bottom, that area will be considered as a total surface area. Excluding top and bottom surfaces, the rest of the surfaces area will be called as lateral surface area. This is a very, very important. Lateral surface area and total surface area. Simply surface area, if you said surface area, it will be total surface area only. But here we are using another word called as CSA, curved surface area. For a cube, all faces are squares. For a cuboid, all faces are either either squares or rectangles, maybe combination of this, correct? Okay. So, that is the reason we call lateral surface area. Okay. They are either in the form of a triangle or in the form of square, in the form of a rectangle. So, those were called as laterals, clear. But in some 3D shapes, for example, if you take a cone, so what is the bottom of the cone is in the shape of circle, but top is, it is a curved surface. So, we use that word as a curved surface area, is it clear? So, which 3D shape has a curved surface, there we are using curved surface area. Which 3D shape has the sides simply either in the form of a rectangle or a square, we use the lateral surface area. Okay. So, here the area will be called it as LSA or CSA, and the second one is TSA, total surface area. Okay. Now, the third one is a volume. So, what is the volume here? How much space it was occupied, that is called a volume. Okay. Simply the volume of any object, 3D object is base area into height, that is it. So, any one, so base area into height will be considered as the volume of the 3D object. So, these are the three parameters to measure the nature or the properties of the 3D shapes. One is called it as a perimeter, second one is called area, and third one is a volume. So, especially for this mensuration chapter, the formulas are more important. Different kinds of 3D shapes. So, that is one is called cylinder. Okay. So, now we will observe it, the Coca-Cola drink bottle, it is in the shape of cylinder. So, electrical cell, it is in the shape of cylinder. Okay. Tomato soup tin, it is in the form of cylinder. Of course, dustbin also it is in the form of cylinder. When you coming to the die, to play the die, of course, to or some games, Ludo game or something, it is in the form of cube, correct? And the other one is also a cube, you know that changing the colors. Okay. So, these are the different shapes of 3D shapes. So, what is very objective of this concept? So, visualization of 3-dimensional shapes by their nets is very important, and the second one is develops the 3-dimensional shapes by understanding their nets, and the third one is develop the skills of preparation of toys. Okay. Through this chapter you can understand how to prepare the toys also. The next one, develop the skills of preparation of models like kaleidoscope, pinhole camera, etc. These are the objectives of the learning of net shapes of the 3-dimensional shapes. Okay. So, for the preparation of this competitive examination, so the objectives is a little bit varied from this one here. This is very important. You have to visualize, there is a possibility of conversion of one kind of solid to other kind of solid. So, for example, if you want to prepare the candles, okay. So, if candles, so then how you are going to prepare the candles? We will take the rectangular or a cuboidal wax, am I correct? So, they will collect as a raw material. A cuboidal wax will be collected as a raw material, by that it will convert it into cylindrical candles, correct? Otherwise, a cuboidal iron iron piece will be converted into spherical balls, which is used to reduce the friction in the various machines, am I correct? So, if you want to, how many for example, some quantity of the volume of an iron piece is given, how many spherical balls will form by the given dimension. If you want to calculate, you have to know the formula of a cuboid, volume of cuboid. At the same time, you have to know the volume of a sphere. This is a very, very important. Of the part which is cutted into horizontally, that will be hemisphere. So, we have hemisphere, am I correct or not? Frustum is also there. So, but these are the development of you have to understand all the things. So, that is a visualization of three-dimensional shapes is very, very important. Now, come to the next one. It develops the three-dimensional shapes by understanding their nets. Okay. So, when you open it, so generally bihatting is not the correct one. So, you have to understand how, for example, if you want to know that the lateral surface area of a cube, lateral surface of cube is simply 4a square, and the total surface area of the cube is 6a square. So, if you by heart that, you may forget, but if you understand the net shapes, then it is easily. When you open it, I will show it how the net shapes also will be like. So, when you open it, so you will get totally 6 faces, okay, excluding top and bottom, means two square areas will be deleted. Then what is the remaining part here? There are 4 squares. The area of each square is a square. If the length of the side of a square is a, then a square. So, a square, 4 a squares, means here simply the lateral surface area of a cube is 4a square. When you consider the total surface area, means considering top and bottom, it will be 6a square. So, like you can find out. Okay, now come to the next one. It develops the skills of preparation of toys. Of course, this is not necessary, but it is a practical use. It is a practical use of for this, and you can understand where this these things will be used, and means in the preparation of the models like a kaleidoscope, pinhole camera. All these are very useful thing. Okay, now coming to the what shape of this? Can you identify this? What shape of this? So, just each part is in the form of a square, am I correct? Each part. So, means here how many squares are there? Count it, 1, 2, 3, 4, 5 vertically, and other sides you have 2, totally 6. There are 6 faces. So, 6 faces means just now I discussed, I think so, that is a cube. A cube has 6 faces and all are in the form of square. So, it is a net shape of cube, am I correct? So, we will see this is it correct or not? Yeah, it is a cube. So, when the cube is opened in the form of net, it is in the, so we can show the cube in various net shapes, but it is a basic net shape. So, simply from this you can calculate the lateral surface area and total surface area. Even you can calculate the volume also, am I correct? Now, just verify it. So, we have 6 square areas. So, 6a square is the total surface area of a cube, and when you exclude the top and bottom, which are shown, just observe it, which are shown on either side of that things. So, simply we are excluding 2 areas of squares, that is 2a square, 6a square minus 2a square, which is equal to 4a square. That is called the lateral surface area. And if you want to know the volume of it, so what is the volume of the things means here? Just now I said the formula. Volume of the things means here. Why I gave the formula means here? When you pile it 1 by 1 square on, so there, so for example, there are 4 centimeters square, 4 centimeters length square was there. Means you put it into 4 like then you come into the piles, then a cube will be formed, am I correct? So, the pile of squares will form a cube, means here height. So, there are 4 centimeters length, 4 centimeters breadth and 4 centimeter height, means how many, and so you have to pile 4. Then a 4 centimeter length of a cube will be formed. What is the area of that here? 4 centimeters length and 4 centimeters, of course breadth is also length here equal. So, 4 of 4, 16. The base area is 16. Okay, the base area is 16 and the height is 4, means here 16 4s 64. The volume of the cube is 64 cubic units. If it is in centimeters, a cubic centimeter. If it is in meters, it cubic meters. Like you can say that. Is it clear? So, the volume here is simply the base area into height. clear. How volume will be considered? The pile of the bases. So, when you take the pile of the bases, it forms as a cube. Okay. Now, come to the next one, what shape of this? What shape of this? Maybe you have some idea, I think so. For example, you want to purchase some groundnuts at the beach road or any shore of the tank, then generally they will sell these groundnuts, okay, roasted groundnuts. So, if you want to purchase for it, what you have to do? Simply you have to, they will take one kind of shape. What shape of it is? It is a cone, correct. It is a paper, then just they will close it in the form of a curved shape. So, when you form in the curved shape, a cone will form which is open at the top. So, when you close it, like when you take a cone ice cream, okay, cone ice cream, then see that it is closed at the top. When you keep it on that, it forms as a cone. Now, you can recall that when you open the top of it, when you keep it there, and when you open it, you can see that it is simply it is a form of cone. Am I correct? Okay. Now, we will check it whether it is correct or not. Absolutely, it is a cone. It is a net shape of cone. So, why this means here? It is useful for in the mental ability test also. So, very useful also. So, you can see that. So, in the pictures, okay. So, they will give the problem figures. When you see that, you can understand this kind of application also. So, net application also is very useful. That is the reason for this class may be useful for you in the form of multi advantage. That is the reason we are explaining in a clarity way. What shape of this here? So, here all are in mostly rectangular shape, correct. So, if you see that the vertically there are 4 rectangular shapes, and when you take an outsides, so it is in the square shape, correct. So, can you imagine what shape of this here? So, when you take a cartoon of biscuit packets or some chocolate packets, when you open it, maybe you identify this kind of shape directly, it seems to be like a cuboid, correct. So, cuboidal shape. So, generally when you see that one top and bottom in one particular view, top and bottom is in the form of square, and the rest of the things is in the form of rectangle. So, it forms as a cuboid. Now, we will check it whether it is a cuboid or not. Yes, it is. It is a cuboid. When you see this cuboidal shape, when you open the total, so either side of that and the square shape, and the rest of the 4 sides will be in the rectangular shape. So, we can identify when you close it. So, a cuboid will form. When you cuboid will open it in all the directions, it seems to be like this. Clear? Okay. Now, we will check this. So, what shape of this? This is very important. What shape of this? This previously you observed a curve means nothing but it is like a sector and a circle. A sector and a circle, so it gives as a cone. But here a rectangular and 2 circles added. Okay. So, for example, if anything for a shuttlecock container. So, shuttle, when you cut it into vertically, what you have observed, it. So, it's open it like it's in the form of a rectangle. Am I correct? It is in the form of a rectangle. So, when it is in the form of the rectangle, and the top and bottoms will be in the form of circles. Okay. So, maybe in the next episode I will show it by using the software GeoGebra how it will form in a animation method. So, maybe you understand more effectively than this. So, just observe that. After that, imagine it. That is a visualization and representation is the most important task to anyone when you are going to visualize. I will give a small example. So, when you take a triangular shape sheet, just on the top or keep it into just paste it into an vertical stick and rotate it and rotate for some time. What kind of image you are going to be perceived? So, for example, that triangular shape is moving in a clockwise direction or anti-clockwise. What kind of shape you can observe? What kind of shape? Can you imagine it? It will be in the cone shape. Am I correct? Okay. If it is a rectangle, so take a rectangular sheet and rotate it into a circular path. What kind of shape you can identify? That is a cylinder, correct. So, this is very important, especially mensuration chapter, you have to visualize the things properly. If you have this proper idea of it, that comes under the surveying, it comes under the surveying. There is a field, it is a shapeless field. So, it is nearer to maybe trapezium shape, or maybe it is in the pentagon shape, or some different kinds of shapes. So, you have to utilize the maximum area without wasting for the construction. So, you have a good visualization about the net shapes of these 3D shapes. So, this is the most important. For that reason, we are taking the first concept in the mensuration as nets. Okay, so when you open it, so what kind of shape it is? So, it is very clear, it is a cylinder. So, cylindrical shape is in the form of, am I correct? Now, check it very clearly. So, the top and bottom are in the shape of circles, and the middle one is in the shape of rectangle. So, just imagine it, both sides are open into the curve path. Top and bottom will be adjusted. Then what shape of things you will call? Just observe it, it is a cylinder, correct? It is a cylinder. What shape of this? So, when you take it as a shape, so there are some 1, 2, 3, 4, 5, 6. So, 6 rectangular shapes is there. So, when the 6 rectangular shapes and other one is it is 1, 2, 3, 4, 5, 6. So, it is that shape is hexagon, correct? So, there is a concept we call it as a polygons. So, what is meant by polygon here? So, a closed plane figure which has n sides is call it as a polygon. So, polygon means simply we can call it as a closed plane figure which have n sides. If it has 3 sides, it is a triangle. If it is a 4 sides, it is a square. Or of course, is a quadrilateral. If it is a 5 sides, is a pentagon. If it is 6 sides, hexagon. 7 sides, septagon. 8 sides, hectagon. 9 sides, nanogon, and 10 sides is a decagon. Of course, I said 7 sides is septagon and 8 is octagon. So, like we can call it. Now, we will see what kind of things here it will form here. Now, clearly observed as it is hexagonal prism. It is a prism. Okay, hexagonal prism. So, why it is a hexagonal prism? So, how many of course, the sides for the bottom? Just observe it, count the sides. Just now I said 1, 2, 3, 4, 5 and 6. For 6 for hexagon. Once again I am repeating that the 3 triangle, 4 quadrilateral, 5 pentagon, 6 hexagon, 7 septagon, 8 octagon, 9 nanogon and 10 decagon. So, it is a hexagonal, it is a prism, clear? Okay. So, we can say the shape of this is a hexagonal prism. Okay. Now, coming to the next one is what shape of this? This is the most important. So, like it seems to be like a what you call it as a star, correct? It seems to be like a star. So, when you close it, can you imagine it? That's a, so all are in a triangular shapes, correct? 1, 2, 3, 4. So, 4 triangulars, okay, at the base is a square. So, imagine it seems to be, okay, when you close it, it seems to be like it's a pyramid. This is the most important. Of course, we have it's one of the pyramid, everyone knows it. It's one of the 7th wonder pyramids in Egypt, you know that. So, that is call it as a pyramid. When you see that all the sides, of course, laterals are in the form of triangles and base is in the form of square. So, it is simply we call it as a triangular pyramid, okay, or simply we call it as a pyramid. This is most important. When you come into the what shape is this? What shape is this? So, can you imagine what shape of this is? Can you imagine it? So, we can imagine simply there is a different shapes. So, maybe I said this one is the first one is all are squares. How many sides? 1, 2, 3, 4, 5, 6. So, there are 6. So, definitely it forms as a cube. Okay, this is the most important. Even when you take any one, so simply as a cube. What shape is this one? Simply we call it as a cube. Clear? Just observe it. Means here the cube can be arranged, the net shape will be arranged in the different way. So, sometimes in the mental ability question different kinds of the things will be given. So, you have to find the odd man out, the net shape of one object. Okay, they will give them, which is an odd man out, means here you have to check it. So, which has the 6 squares, combination of squares, that will be called it as a cube. That is most important. Okay, and now coming to the next one, what shape of this? So, what shape of this means here we can say simply by closing all those things you can identify. The very important thing is coming to this one, it is a pentagonal prism. Pentagonal prism. Why we said is a pentagonal prism? See that the sides of the bases here 1, 2, 3, 4 and 5. It is a pentagonal. So, pentagonal prism. You know that prism has a good application. Prism has a good application, correct? So, when the light ray incident on a prism, it reflect the total ray, it's scattered the total ray as 7 colors. Of course, we call it as a 𝗧𝗦𝗔𝗧, violet, indigo, blue, green, orange and red. So, that is a rainbow will be formed, correct. So, a water drop on a leaf also act as a prism. Prism always need not to be in a triangular shape. So, there is a myth in the minds of the students. So, prism means here it is always a triangular prism. So, in the laboratory we are observing a triangular prism. So, different kinds of prisms also there. It is a pentagonal prism. If the based on the base, we will name the prisms as a pentagonal prism, triangular prism. So, the shape of the base is triangle, then we call it as a triangular prism. The shape of the prism, of course, the base of the prism is in the form of is in the shape of a pentagon, then we will call it as a pentagonal prism. This is most important here. So, we are going to convert a 2D to 3D, that is a very important. You have to identify a 2-dimensional figures and the 3-dimensional figures, especially a 2-dimensional figures has a 2 dimensions. So, in general we will call a length and breadth, rectangle, square, okay, circle, triangle, quadrilaterals, all comes under the as a 2-dimensional plane figures. It has a perimeter and a area, and whereas when you come into the all these things what just now I discussed as cube, cuboid, okay, and you can call it as cone, cylinder, prism, pyramid, all comes under the call it as a 3-dimensional space. Even sphere also comes under the 3-dimensional shape. And when you consider the hemisphere also comes under the 3-dimensional sphere. So, there are some combination of the solids also. So, combination of such solids also you have to identify, for example, a tablet which is in the form of combination of 2 hemispheres, 1 cylinder. Is it clear? When you take a water tanker also is in the form of combination of 2. What is the combination of 2 here? Simply it is in the shape of a cylinder, and either sides are in the shape of hemispheres. So, like you can take it as a ice cream cone. When you take an ice cream cone, when you observe the ice cream cone, so it is in the form of cone and hemisphere. Clear? When you consider a hut, it is in the form of cuboid, and the top hut is in the form of pyramid, correct? Like we can identify the things. This is a most important. Now, coming to this one. So, what shape of this? It is a very important. Okay, so see that. Can you imagine that all are in the triangular path? So, everyone is in the form of triangle. So, everyone is in the form of triangle means you can say the triangular path is simply 1, 2, 3, 4, 4. When you close it, what will happen here? Simply, so a prism will be formed. Just now I said about the prism, we will check it whether it's a tetrahedron, correct? So, it's a tetrahedron. So, we have totally 4. So, that is the reason we call it as it is a tetrahedron also. So, that is very important. So, generally we will not use it as a prism, the word will be call it as a tetrahedron. So, that is things very important. Now, coming to the another shape, what shape of this? This when you can you observe it? So, there is some rectangular or a square and the next one is a triangular shape. So, when it is in the form of triangle, so what you have to identify, can you imagine it? That is it comes under the triangular prism. Already I said this a triangular prism, generally the triangular prism used for the experiments. So, like light experiments and especially we are using in the optics to learn the properties of light. So, that is very important. So, when you consider this is for example, if I ask to you what is the total surface area of a cuboid, what is total surface a cuboid here? So, how many sides here? Now, you can say it as 2 times of LH plus BH plus LB, like you can say it, or you can say for example, if you want to know the curved surface area of that is pi r square L. Okay. And when you consider it, what is the volume of volume of a cylinder? So, when you take a volume of cylinder, anyone can you say that volume of a cylinder means? Simply you can say what is the base of a cylinder circle, what is its area? Pi r square. What is the height? See, if you say h, pi r square h. Clear? So, the volume of a cylinder is simply as pi r square h. If I ask you to what is the volume of a cone? So, volume of a cone is very important, and the volume of cone means generally the volume of a cone which has the same height with the cylinder and base radius is same, then that will be 1/3 of it. Then simply you can say the volume of a cone of height h and the base radius is r, simply 1/3 pi r square h. Clear? So, this is the most important, like you can find the volume of various 3D figures. So, that is most important. When you come into this kind of this, what shape of this? When you observe this, so there is some on the top one is count all the sides of that 1, 2, 3, 4, 5 and 6, it is a hexagon shape. The next one is a rectangular shape, the below one is hexagon shape. So, anyone can you assume that what kind of shape is this? This is most important, it is a hexagonal prism, hexagonal prism. So, we can identify the hexagonal prism also. So, these are the different things we are going to learn it. You can convert. So, it is nothing but a conversion of a 2D figures to 3D figures. See that the net shapes gives 2D figures, and when you close it, when you make it into an object, it gives us the 3D figures. So, like it is a conversion of 2D figures to 3D figures, that is a very important. So, you can convert one kind of figure to another kind of the figure, that is nothing but it is a conversion. So, generally we have a conversion of 3D figures from 2D to 3D or 3D to 2D, and a combination of also is a very important concept. Now, coming to the, so just it is I gave a small exercise to you to practice it. So, you can draw the net shape of a pyramid, and some 3D shapes have more than one net, find out. This is a very important. So, when you observe it, those nets, what kind of things here. So, you have to practice, this is the most important, you have to practice the shapes of various figures. Net shapes is a very important. You have to identify and you have to tabulate the total things, especially the total things means here you have to make a format, that is perimeter, area, and area will be as a total lateral surface area or curved surface area and total surface area, and the next one is you have to identify the things, that is a volume of it. So, once you know the formula, that is most important. For example, I gave a small question to you, maybe comes in the examination, that is a cuboidal wax is converted into cylindrical candles. How many candles will form? That is the question. How to do that means simply find the volume of each candle. and find the volume of the cuboidal wax. Divide the volume of cuboidal wax by the volume of each candle, cylindrical candle, simply it gives the number of candles formed. So, very simple, it is a very useful also in the examination. When you use this concept, you will get the answer. At the same time, when it is a combination of solids means for example, when you want to find the volume of for example volume or the total surface area, for example total surface area of ice cream cone. What is it? So, ice cream cone is a combination of two. One is hemisphere and second one is a cone. So, simply find the curved surface area of a cone, curved surface area of the hemisphere. Just join this, it gives the total surface area of the ice cream cone. Am I correct? So, like this is the most important. You have to identify the objects which are in the different kinds of shapes. After identifying the shapes, find the lateral surface area or the curved surface area, add all those things which gives the total surface area of the combination of solids. So, this is the most important. Okay. And coming to the next one, you have to identify the relations, that is the most important. So, when you consider a cylinder, already said the volume of a cylinder is pi r square h, but with the same base area with the same height, when you consider a cone, the volume of the cone will be 1/3 pi r square h, like this is a relation between it. And the volume of any 3D object is based on one formula, that is called it as base area into height, which gives it. So, no need to by heart it, just now I said So, for example, if you want to find the volume of a cylinder. So, what is the volume of cylinder? How we are going to find the volume of the cylinder? Simply you have to identify that the volume of the cylinder's base is in the form of circle. So, its area is pi r square and it is in the form of height. Height is say h, then it is said to be pi r square h. Okay. So, base area into height, which gives the pi r square h. Is it clear? So, like you can find the volume of the, and now coming to the next one is very important is after formulas, which formula you are going to use, that is a very important. First, when you take it as sometimes there are so many 3D shapes are combination is given, you have to identify the shapes first. After identify the shapes, which one is required. For example, they want to paint one object. So, when you for example take a water tank, they want to paint it. Here which surface area are going to use it, whether lateral surface area or total surface. For a water tank, generally you won't paint for the bottom and we won't paint in general for the top. So, top and bottoms are not to be painted, only you have to paint for the laterals. So, simply there you have to find the lateral surface area, clear. And sometimes for example a cuboid is given. So, cuboidal box you have to paint, the top, bottom and everything. So, there you have to use the total surface area. So, like you have to identify where you are using the lateral surface area and where you are using the total surface area, that is most important. And another thing is the language of mensuration is very important. So, there you are using some words, call it as a lateral surface area, total surface area, volume of the thing, a pile of the things. All these words are, so this terminology also very important. So, what you have to do for preparation of this especially mensuration, you have to write each and every two-dimensional figure and its area. I will give a small example. When you take it as an equilateral triangle, there is a good relation between height of the equilateral triangle with the base. Okay. It is √3/2 times of A. If A is the side, means the height of the equilateral triangle is √3 times to its side, that is h is equal to √3/2 A, and area of equilateral triangle is √3/4 A square, clear. So, that is a very important. For an isosceles triangle you can use half base into height, for a right angle triangle you can use the, and for right angle triangles very important. So, if you know the Pythagorean triplets, then it is easy to that. There is a Heron formula is there. So, you know that Heron's formula. What is the Heron formula? When you consider the Heron's formula, simply we can say the Heron formula is area is equal to root over S of S minus A of S minus B of S minus C. This is the formula. So, what is S here? S is the semi-perimeter. Semi-perimeter means here we can say A plus B plus C. S is equal to A plus B plus C by 2. That is called the semi-perimeter. Okay. And very important thing is once you know that semi-perimeter, then it is easy to that in radius R equal to delta by S. Here delta is the area of the triangle, of course area of the triangle, and S is the semi-perimeter. Also like you can find the in radius. This is a very important concept which is used in the finding those things. Now coming to the circles, you know that a circle has the area of a circle is a pi r square, and area of a semicircle is, and one more important thing is the diameter of a circle is simply the diameter of a circle is 2 times of the radius of the circle. This is a very d equal to 2r, simply you can say d equal to 2r. Clear? And one more important thing in this especially in the circle especially in the circle, there is a sector. So, here the sector means here you can find the area of a sector A equal to LR by 2. L is the length of the arc and R is the radius of the circle. So, A equal to LR by 2. If you does not know the length of the arc, then you can say by using x degrees by 360 degrees into pi r square. That is a formula for it. Okay, x degrees by 360 into pi r square means here x degrees is sector angle. Okay, and if you want to know the length of the arc, L is equal to x degrees by 360 into 2 pi r. So, like we can apply these formulas, I can find it so for triangle. Even for when you take a square, the area is a square, and A is the length of the side and the perimeter is 4a. If it is a rectangle, the area is length into breadth, and of course perimeter 2 times of L plus B. Okay. If it is a quadrilateral, there are so many kinds of quadrilaterals are there. You know that a trapezium is there. Simply for a trapezium, the formula is h by 2 of A plus B, where h is the height or the distance between the parallel sides. A and B are the lengths of the parallel sides. Okay. If it is a rhombus, we can say of D1, D2, where D1, D2 are the lengths of the diagonals. Okay. And the very important formula is, for example, if you take it a cuboid, you have length, you have breadth, you have height. So, 𝗹𝗵𝗁. If you want to know the diagonal of a cuboid, so simply is root over L square plus B square plus H square. So, like you can find the even for a rectangle, what is the length of the diagonal? Simply it is root over L square plus B square. The very, very important thing is the relation between angles and the triangle. Okay, sides. So, simply we can say the angles are, for example, theta 1, theta 2, theta 3, and sides will be in the ratio of sin theta 1 is to sin theta 2 is to sin theta 3. Clear? That is a very, very important. If it is a right angled isosceles triangle, so what are the angles here? 45, 45, 90. Am I correct? Then you can say simply apply the sin 45 is to sin 45 is to sin 90. What is sin 45? 1 by root 2. 1 by root 2 is to 1. So, 1 is to 1 is to root 2. Simply we can say 1 is to 1 is to root 2. That is most important. Clear? Okay, like you can say. So, simply, so the sine values of angles of a triangle ratio is equal to ratio of sides. So, this is the relation between angles and sides. So, we can classify the triangles into three kinds, of course, with respect to angles and with respect to sides also. So, as per angles we can say equilateral triangle, isosceles triangle and scalene triangle. As per this one we can call it as, with respect to sides we can call it as equilateral triangles, okay, isosceles triangle, scalene triangle. With respect to angles we can say acute angle triangles, right angle triangles and obtuse angle triangles. So, this is the most important, and you have 4 point of concurrences also. The 4 point of concurrences means here, so one is called it as a centroid, second one is called circumcenter, third one is called incenter, fourth one is called orthocenter. The point of concurrence of medians is called centroid, and the point of concurrence of altitudes is called orthocenter. The point of concurrence of perpendicular bisectors is called circumcenter, and the point of concurrence of angular bisectors is called incenter. So, all these are coincide in equilateral triangles. All these are lies on the same straight line, which is angle bisector of vertex angle in the isosceles triangle, collinear points there, and for the rest of the triangles, rest of the kinds of the triangles, they are in different positions. Okay. So, like we can say this is about various concepts. Okay, now coming to the quadrilaters. When you convert into the quadrilaters, simply you know that for rhombus, so when a rhombus becomes a square, when a parallelogram, this kind of questions also very useful here. So, what is a parallelogram? In a parallelogram, so opposite sides are parallel and equal. If adjacent sides are equal, then the parallelogram becomes as a rhombus. And in a rhombus, one angle is 90, it becomes as a square. See the interrelation between all these things. So, every square is a parallelogram, every square is a rhombus, but every rhombus need not to be square. So, every parallelogram will be a rectangle. Rectangle is a parallelogram, but the converse, which is not correct, means what is a parallelogram? Opposite sides are parallel and equal. If one angle is 90, then the parallelogram becomes as a rectangle. Clear? This is the most important, like a conversion. So, when it becomes as a triangle, these things are very important. All comes under them, and the area of the parallelogram is nothing but base into height. And when you take the two parallel lines, between two parallel lines with the same base, the areas of the parallelograms are equal. Between the same parallel lines with the same base, okay, the area of a triangle is half of the area of the parallelogram. So, like we have good theorems and axioms, all comes under this. You have to practice all these things, then definitely which gives a good idea about the relation between all these things. So, in the part of 2D and 3D figures, in the circles and other things, so you have to learn all these things, you have to understand the relation between all the things.